Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amin Syahmi bin Salahuddin. Our group will present for the mini project for subject power system operation and control. First of all, I will introduce our team member Muhammad Nadir, Muhammad Haris and Muhammad Muhammad. We go for the first part, which is part A, power line carrier PLC communication. So, the introduction of the SCADA system. SCADA means supervisory control and data acquisition. So, SCADA is a category of software application for controlling industrial processes, which is the gathering of data in real time from the remote location in order to control equipment and the condition. So, we go for the configuration of SCADA system. So, this is the SCADA system configuration. So, this SCADA needs system and requirement for the system to boot. An IoT system is being developed for this configuration where it is more advanced than the others. So this system make use of advanced systems in a malfunction configuration. We go for the SCADA architecture. SCADA architecture is divided into three, which is monolithic SCADA system for systems that run in a closed environment without connecting to other systems. Second, distributed SCADA system. So this system were interconnected and limited inside a local arranged network. Third is the network SCADA system. This system is former employers and open system architecture as opposed to a manufacturer and closed environment. So we go for the SCADA major component. SCADA major component is divided into four. First is the human machine interface HMI. Second, remote terminal units RTU. Third, programmable logic controller PLC. And fourth is the communication system. That's all from me. Thank you.
Assalamualaikum. My name is Muhammad Haris bin Mat Gani. My metric number is 1910911054. So, I would like to continue on the SCADA major components and functions. So, there will be four components, which is the first one will be human-machine interface. The human-machine interface is a software component that enables human and machine to communicate and interact. The most popular HMI in industrial application, which is the touchscreen. The touchscreen links users to device and system. It is used in factory operators to operate and manage their equipment and manufacturing procedures. And then for the second one, which will be the programmable logic controllers. The programmable logic controllers is a small computer that is used to automate manufacturing. Certain processes such as machine, operation, and even entire production line can be automated using these controllers. So on the right side, there will be the PLC module. So we can see that the digital and analog input will be go into the PLC and converted the input into output module, which is also can be digital and analog. And then we go to the remote terminal units. Remote terminal units are microprocessors that allow different components in dispersed SCADA system to connect with one another. SCADA relies on RTUs, especially when communicating over long distances. They are used for remote monitoring of situations such as fluid levels. And then we go to the communication system. A communication system may be internet-based, allowing data from RTU to reach HMI, human machine interface, and then be used to send orders to the PLC, programmable logic controllers. This system allows different components to communicate with one another and also make SCADA system operate smoothly. So, in SCADA communication and protocols, there will be two protocols, which is the first one will be Distributed Network Protocol, DNP3. So, DNP3 is used to communicate among substation components in SCADA system. The protocols were created to make it possible for RTUs to communicate with one another. It is often used in utilities companies such as water and electricity companies. So, on the left side, you can see that there will be three PLC modules. So the first module will be the master module, and then the two module will be the slave module. And then we go to the SCADA communication and protocols. So the second one will be the open system interconnections, which is the OSI. The bottom for so the layer which is it has 7 layers, which is the application layer, presentation layer, session layer, transport layer, network layer, and data link layer, and also physical layer. So the bottom 4 layers, which is from physical until transport layers, is usually the physical wiring, networks, and communication protocol for both local and wide area networks. So this design eliminates the requirement to understand the complexity of the network and enables to the communication to become independent of the established system. So in a SCADA communication protocols networks, not all networks use these layers. The standard RTU protocols transfer data from field RTUs, the remote terminal units, to a SCADA workstation in a consumer-friendly manner at the application layer. So I guess that's all from me, and then I will pass it to Nadir. Thank you.
Assalamualaikum and hi madam. My name is Muhammad Nadir bin Rosli. So I would like to continue our presentation by starting with a contribution of SCADA system in power system. So SCADA in power system is limited to distribution voltage and has a similar purpose in distribution and transmission applications. It is often used to gather analog data and information such as load current, bus voltage, power and power factor, as well as to keep an eye on breakers and switch at the distribution level. In transmission applications, SCADA systems are also used to focus system information so that transmission operators can be scheduled generation and load dispatch. So next, we will go to advantages of implementing SCADA system. One of the advantages is that it can manage the system remotely from the station. Each SCADA system is built by a number remote terminal units, RTUs, that collect data in the field and transfer it back to the master station over communication channel. At the same time, accurate, timely data necessary for a SCADA system to optimize the operation of the process. As a result, the SCADA system runs more dependably, efficiently, and safely. In addition, SCADA system may store a lot of data which can then be viewed and displayed in any type of format depending on the requirements of the user. This system can vary out various monitoring and controlling duties by connecting hundreds of sensors over a large area. As a result, the SCADA system can be modified or varied. So lastly, the advantages of SCADA system: it can enhance plant and process operations that leads to cost saving. The users of the SCADA system can also take advantage of its powerful trading capability to anticipate problems in the future. Next, we go to the disadvantages of SCADA system. One of the disadvantages is that many wires were usually used by the SCADA system, especially in older technology. The most important problem with this cable are electrical noise and interference. This cable has a unique combination of problems. Thus, this electrical noise may cause circuit to malfunction and even endanger system equipment. So next, the cost to install the SCADA system may be expensive. This is due to the fact that when a new system is being introduced, its quality must be taken into account. In business, there is no such things as an infinite budget. Cost consideration must be weighed against performance and integrity standards in order to deliver an effective operating system at project end. Therefore, it is crucial to consider the installation costs. Last but not least, the advantages of the SCADA system is the PLC-based SCADA system is complex in terms of its hardware parts and related modules. Because the system is complex, it needs to be maintained by a trainer operators, analysts and programmers. Therefore, this problem may also cause unemployment rates to rise. So next, we'll go to the part B, which is the application of SCADA system in power system. So the first one is real application of SCADA system in power system. So the one of the real application that use the SCADA system in power system is floor elevators. The floor elevator is the SCADA system preferred application in the power system. In both residential and commercial settings, elevators are a typical model of vertical transportation. The rapid urban population growth and rise of multi-story structures have increased the demand of floor elevator. Elevator systems are getting better due to the increasing living standards, attention to the human requirement, and technology improvement. They are getting quicker, stronger, and high quality. So next, architecture combination of others component. In general, SCADA is just combining of hardware and software components that enable the system to communicate directly to the others object, including sensor. This gadget and sensor take actual data reading of variables like temperature, speed sensor, or weight. The data is transmitted to a PLC or RTU, where it's converted into information that can be interpreted and used. Thus, this section will talk about the other part that connect to the SCADA elevator system. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Muhaimin bin Muhammad. So now I will continue to present about the architecture combination of other components. So I will present about the first component, which is PLC controller. PLC controller is a small computer that has inputs for data and outputs for sending and receiving commands. The PLC model that has been used in the system is we call S7200 PLC. The second component is stepper motor. The stepper motor is an electromagnetic device that transforms digital pulses into mechanical shaft rotation. It has many benefits when used the stepper motor, such as affordability and excellent durability. Next component is inductive proximity sensor. It is used to find the elevator without physically touching it. They are so important in automation application because of the small size and the high speed switching. And the last component is button. So the button is used to call an elevator cab to the floor when they are located. It also will be controlled by a floor request buttons elevator controller. And this button opens the elevator door when the elevator cab stops at the floor. So next is the working principle of floor elevator. At the first point is first the elevator that is used in daily life serves as the function of the PLC for the system. The elevator that most people use is moved by the three-phase AC motor, a pulley on its facilities that lift upward and the downward motion. And point number 2 is the power supply provides energy to both the PLC controller and the motor drive. The motor drive units power the elevator motor. And point number 3 is the elevator is connected via human machines interface, HMI, software, and is controlled by a SCADA system. So we move to the conclusion that we get from this SCADA system. First, this SCADA system is enable business to monitor, collect, and process real-time data while controlling industrial operation locally and remotely. It also enables direct communication with smart device and application for human-machine interface, and it records data. It has also enabled an organization to truly research, forecast, and consistently carry out the best reactions to assess condition. So it's more intelligent machinery, and PLC will be able to integrate various cloud systems. So that's all from me. Thank you and Assalamualaikum.